Imagine a universe so immense it stretches beyond anything we can truly comprehend. A boundless expanse of darkness, dotted with distant lights. These tiny pinpricks of starlight and faraway galaxies are the only hints of what lies out there. Since the dawn of civilization, humans have gazed upward, captivated by the mysteries above, and wondering about our place in the cosmos. The night sky has always been a canvas for our imagination, a frontier with no clear boundaries. Our urge to discover has led us from scaling mountains and diving into oceans to finally reaching for the stars. We invented powerful telescopes to peer deeper and rockets to escape our planet's grip. Each breakthrough only deepens the enigma, revealing new puzzles and marvels. Space isn't just a void, it's alive with astonishing wonders that defy our everyday experience. Monstrous black holes, vibrant nebulae, and a multitude of worlds. Some eerily familiar, others utterly strange. Every observation is like receiving a message from a realm we can only dream of visiting. That's why we send robotic explorers, our mechanical ambassadors, to venture where we cannot. Crafted from our ingenuity and curiosity, these probes journey into the unknown on our behalf. They carry our questions, our hopes, and our longing for discovery into the silent depths. Their odyssey is a reflection of our own quest to understand the universe. What they uncover reminds us that we are just a small part of a much grander story, and as we continue to explore, the greatest adventures in space are still ahead of us. In the late 1970s, humanity launched Voyager 1 and Voyager 2, two spacecraft destined for the outer reaches of our solar system. Their mission, a grand tour of Jupiter, Saturn, Uranus, and Neptune, made possible by a rare planetary alignment. Voyager's instruments captured breathtaking images and data, transforming distant points of light into dynamic worlds. But Voyager carried more than science, it carried the golden record, a time capsule of Earth's sounds, images, and greetings for any who might find it. The mission's success was spectacular: active volcanoes on Io, Saturn's intricate rings, Uranus's tilted axis. Each discovery reshaped our understanding. After their planetary flybys, the probes pressed onward, heading for the edge of the sun's influence. Voyager became our first emissary to the stars, sending data from the very boundary of interstellar space. Decades later, these spacecraft still journey outward, carrying our story into the unknown. Their mission is a testament to human curiosity and ingenuity. Voyager's legacy is not just in what it found, but in how it changed the way we see our place in the universe. The journey continues. Years after its planetary tour, Voyager drifted through the Kuiper Belt, a vast icy region beyond Neptune. The sun was now just a bright star, and Voyager's instruments scanned the profound darkness. Most data was routine, until something changed. The imaging system detected a tiny moving point of light. Unlike distant stars, this object shifted position over time, a sign it was much closer, within our solar system. The mission team on Earth felt a surge of excitement. What had Voyager found? The object was too small and faint to be a known planet, and its path didn't match any familiar bodies. It was something new. In this unexplored region, any discovery is significant, but a moving object is especially intriguing. The team knew this was the kind of moment that makes space exploration thrilling: the unexpected, the unknown. The moving dot became a new question mark on our map of the solar system. Now, the challenge was to turn that question into an answer. The patient work of scientific investigation was about to begin. All eyes were on a single, mysterious flicker in the dark. With a mysterious moving object detected, the scientific process kicked into high gear. The Kuiper Belt is home to trillions of icy bodies, so the first suspects were asteroids or comets. Asteroids are rockier and more common closer to the sun, but a comet was plausible, though this object was too far and cold for a glowing tail. If it was a comet, it was dormant, a silent wanderer in the frozen dark. Another possibility: a previously unknown dwarf planet or Kuiper Belt object, like Eris or Haumea. Determining its size and orbit would be key. If it was big enough, it could even be a candidate for a new planet, though unlikely. The most tantalizing option, something entirely new, perhaps even an interstellar visitor like Oumuamua. Voyager's aging instruments offered limited data, making the investigation a cosmic detective story. Scientists had to use every clue to eliminate possibilities and zero in on the truth. The identity of the object was a puzzle waiting to be solved. The hunt was on. To solve the mystery, scientists became detectives, using Voyager's data as their primary tool. By tracking the object's movement from Voyager's perspective, they calculated its orbit using parallax, like watching your thumb jump against a distant background. They searched astronomical archives for past images, hoping to find a forgotten clue. Each new data point refined the object's path through the solar system. Computer models tested different scenarios: comet, KBO, or something else. Comparing simulations to real observations narrowed the possibilities. Analyzing the faint light, they guessed at its composition. Reddish hues suggested organic molecules, gray hinted at rock. The process was slow and painstaking, requiring patience and collaboration. Teams across the world worked together, piecing together the story of a faint, anonymous flicker of light. Slowly, a picture began to emerge. The cosmos was giving up another of its secrets. Deep space exploration is a unique thrill, a mix of suspense and discovery. For the Voyager team, communicating with a spacecraft billions of miles away was a daily challenge. Signals took hours to cross the void, and every command was a leap of faith. The discovery of the anomaly amplified the excitement. Each new data packet was a potential breakthrough. The team gathered around monitors, waiting for the latest image or reading. Would the object still be there? Did the data confirm their calculations? Voyager's technology was old, its signals faint, but the team's creativity kept the mission alive. Problem-solving became part of the adventure, a testament to human ingenuity. Science is rarely about sudden eureka moments, it's about the slow, methodical accumulation of evidence. The dedication of the team, working for years to answer a single question, was inspiring. The reward, to be the first to see a new object in our solar system, to chart its course, to make the unknown known. These moments connect us directly to the vast universe we study. The cosmos feels a little less empty, and a little more ours. After weeks of analysis, the team built a profile of the mysterious object. It was a small, icy world, a member of the Kuiper Belt, likely just a few dozen kilometers across. Its stable orbit suggested it had traveled this path for billions of years. Not a comet or interstellar visitor, but a native of the solar system's frozen frontier. The discovery was a vital piece in the puzzle of our solar system's formation. Each KBO is a fossil, preserving a chemical snapshot of the early solar system. Studying its color and density added to our understanding of those ancient conditions. Voyager's enduring capabilities made this possible, even decades after launch. The mission proved the value of having a presence in distant regions. Not every mystery is sensational, but every answer deepens our knowledge. This small world, once a moving dot, is now part of our cosmic map. The solar system still holds many secrets, waiting to be found. The story of Voyager is more than a scientific achievement, it's a metaphor for the human spirit of exploration. Voyager's journey into interstellar space is a testament to our relentless curiosity. Each discovery, like the new Kuiper Belt Object, inspires us and captures our imagination. These missions encourage new generations to look up and ask their own questions. The universe is our greatest laboratory, and every finding adds to our collective knowledge. As Voyager continues, new missions are being launched, like the James Webb Space Telescope and probes to icy moons. We keep building better tools, asking smarter questions, and pushing further into the darkness. The quest to understand the universe never ends. The more we learn, the more there is to discover. We are explorers, and the universe is our greatest challenge and inspiration. Voyager's legacy is not just in its data, but in the enduring idea that humanity can touch the stars. The journey continues, and the greatest discoveries are still ahead.